Nth roots of rational exponents. Here are your state standards and your success criteria. To be successful, you need to be able to explain the meaning of a rational exponent. You need to be able to evaluate expressions with rational exponents, and you need to be able to solve equations using an nth root. Two vocabulary terms today: nth root of a. In general, for an integer n greater than 1, if b to the n power equals a, then b is an nth root of a. Your index of a radical and nth root of a is written as nth root of a, where n is the index of a radical. All right, so in general, this is just, we're going to be rewriting exponents to radicals, so you can go back and forth. And n is your index. So if n is 2, this would be a square root of a. If n is 3, this would be a cube root of a. If it's a 4, it would be a fourth root of a, and so on. Most of the time in this class, you're going to see square roots or cube roots, but you may occasionally see something else. All right, these properties below are very important. Sometimes you see standardized test questions where they literally just take something and rewrite it in different forms to see if you understand what these properties are, if you understand what's equivalent and what's not. So in general, a to the 1/2 power, that's the same thing as the square root of a. So the square root of a is the same thing as a to the 1/2 power. So if we're writing it in exponential form, we've got a to the 1/2 power. If you square that, 1/2 of 2 is 1, and that equals just a. So basically the square root and something to the second power, those two things undo each other. A to the 1/3 power cubed, 1/3 of 3 again is 1, and that represents just a. And then your fourth root, or a to the 1/4 power, to the 4th power, so 1/4 times 4 is just 1, and you can see how that works in each case. So if you have something to the 1/2 power, again, equivalent to square root, then you can square that, and it undoes the half power or the radical or the square root. So it says because a to the 1/2 is a number whose square is a, you can write the square root of a equals a to the 1/2. And again, if there's no number there, that index is missing, that's assumed to be a 2, a square root. Similarly, cube root of a equals a to the 1/3, fourth root of a equals a to the 1/4. All right, so this is pretty important to know. It'll make everything easier if you kind of understand that you can write these interchangeably. So it may give it to you in exponential form and ask you to write in radical form, and they may give you radical form and ask you to rewrite it in exponential form. So that's what it's asking you to know, that these two things are equivalent. Key ideas: let n be an integer greater than 1 and a be a real number. When n is even, okay, a less than 0, there's no nth roots. A equals 0, 1 real root. A is greater than 0, you will have 2 real roots. Okay, it's also important to know when n is even and a is greater than 0, that's this last scenario here, there are 2 real roots. The positive root is called your principal root. So make sure you understand what the principal root is, your positive answer. A lot of times in real life scenarios, your principal root is going to be the solution because the negative would not make sense. The next part, n is an odd integer, a less than 0, 1 real root. A equals to 0, and 1 real root. And a greater than 0, 1 real root. So you can see those all have 1 real root. Okay? Rational exponents don't always have to be just like a 1/2 or 1/3 or 1/4. It may be 3/2 or -1/2 or something like that. If that's the case, this is the property you need. Let a to the 1/n be an nth root of a, and let m be a positive integer. So if you have a to the m over n, example, a to the 3/2 power, then that's the same thing as a to the 1 over n. Just like over here, it was 1/2. 2 would be on the bottom. And then n, or m, would be your exponent, your power. So a to the 1/2 power squared, that would be like 2 over 2, okay? Or in the case up here, let's look at 3/2. So a to the 3/2 power would be rewritten as a to the 1/2 cubed, okay? And that's how that would be written here. All right, if you have a to the negative m over n, again, we're still referring back to properties of exponents. The negative 1/2, remember with properties of exponents, negative exponent means it moves you to the bottom, or if you're on the bottom, moves you up. But we're going to move to the bottom, so it's going to be 1 over whatever. And then the same property up here applies. So a to the m over n, a to the 1 over n raised to the m power. That can be rewritten as the nth root of a to the m power. And again, that's a cannot be 0 because that's in your denominator and it would be undefined. All right, so that is a lot of important information, but sometimes it's more difficult when it's written algebraically. So let's look at a few examples. All right, so to find the indicated real nth root of a, we know that the nth root, that's our index, so we're going to have a cube root of negative 216. And we just figured out that the cube root is equivalent to 1/3 power. So we could say negative 216 to the 1/3 power. So those two things are equivalent, okay? So what we need to do is to find the indicated real root. So how can we break that down? So knowing your multiplication tables helps. I know 5 cubed is 125. I'm assuming this is 6 cubed because 6 times 6 is 36. So let's see what 6 cubed is. 6 cubed is 216, which means negative 6 cubed should be negative 216. And we know that anything cubed is that number times itself 3 times. So we can see that 6 cubed is the same thing as this 3 times. And so negative 6 times negative 6. And again, this just hopefully helps you see how these numbers work together. And that gives me negative 216. All right, so now that I can rewrite that, I know that this equals negative 6. All right, and I do want you to have good number sense. I want you to be able to look at these numbers and try to figure these out on your own. But I also want you to know that there is a radical button on here. Let me see. If you go to math and you come down to number 4, this is your cube root button. So if you hit enter and then you type in negative 216. Well, I missed my 1 here. 216. And then hit enter, it's also going to give you negative 6. And just to be clear that these two things are equivalent, if I do negative 216 raised to the 1/3 power, and I'm putting that in parentheses so I know it's raised to that whole 1/3 power, that should also give me negative 6. So you can see these two things are indeed equivalent. All right, B part says nth root of 81, so 4th root of 81. I know that 3 times 3 is 9, and 9 times 9 is 81. So I'm thinking the 4th root of 81 is 3, but because my index is 4, because that number is even, remember we have plus or minus 3, and positive 3 would be our principal root, thinking back to the vocab. Also, if we wanted to use our handy dandy calculator here, you could type in, go to math, and you come down to x root. That means we have to put the 4 in first. So let's do 4 and then math. Come down to x root. So the 4th root of 81. And that's going to give you 3. It's only going to give you your principal root, but that one would be plus or minus 3, just because if you take 3 and raise it to the 4th power, you get 81. But if you take negative 3 in parentheses and raise it to the 4th power, you also get 81. So the even indexes make it a little bit different. So you got to look at how many solutions you're supposed to have. Anytime this is an odd number, a cube root's always going to have, it can have a negative answer. This one's going to have both a positive and negative. Evaluating expressions with rational exponents. Example 2. All right, so we have 16 to the 3/2 power. Now, yes, you can just simply type that in your calculator if you are allowed a calculator. I can see this being a question on the EOC where you're not allowed to use a calculator. So if you can't use a calculator, a few things that you need to be able to identify. 3/2 is greater than 1. 3/2 is the same thing as 1.5, which means if the numerator is bigger than the denominator, this number, your answer will be larger than this number here. So 16 to the 3/2 power is going to make this base number larger. So how can we do that if we did not have a calculator? So if we don't have a calculator, we could say, using our properties we just learned, we could say 16 to the 3/2 power is the same as 16 to the 1/2 power cubed. And then 16 to the 1/2 power, that's hard to read, so I'm going to rewrite that. All right, so 16 to the 1/2 power is the same thing as the square root of 16. Well, hopefully everybody knows the square root of 16 is 4, and 4 cubed is 64. So it's very possible to do this without a calculator. Again, if you want to use your calculator, if you're allowed to use your calculator, 16 raised to the 3/2 power. You may or may not have to use parentheses here. I always use parentheses just to make sure that it's raising it to that whole power. So 64 is the answer if you type it in. But again, make sure you understand the properties so you can do that even without a calculator. B part says 32 raised to the negative 3/5 power. So the very first thing we need to do is rewrite this using property of exponents. 1 over 32 to the 3/5 power. All right, so that is equivalent to the 5th root of 32 cubed. Now I know that the 5th root of 32 is 2 to the 5th power. I know 2 times 2 is 4, times 2 is 8, times 2 is 16, 16 times 2 is 32. So the 5th root of 32 is 2. And hopefully you have pretty good number sense and you can figure that out fairly quickly. And then 2 to the 3rd power is 8. So the answer is 1 over 8. If you want to use your calculator, if you're allowed to use your calculator, make sure you know how to do this without a calculator in case it's needed. But if you have a calculator and you're allowed to use it, you could type this in as 32. And you could do the negative 3/5 power. And then if I click enter, it gives me 0.125. And all I have to do is go to math, fraction, and it's going to tell me that that is equivalent to 1/8. If you want to use the radical button, if you want to use the second step, you can do 1 over. And let's do 5th root of x root would be 5, so that makes that a 5th root of 32. And I did need that in parentheses. Let's see if it'll let me put that in parentheses. And then I'm going to cube that. and it should give me the same answer, which it